Okay, Assalamualaikum and good morning. I hope you can hear me. So maybe,
Salam.
today I would like to share or touch about a friend. Uh, so we will talk about subtopic, some subtopics under a friend like performance, yeah, and then we will touch about also about how to fan selection in the hatchback system. Okay, anybody can see the slide visible from your side? Is it possible? Is it
Yes, sir.
visible? Yeah. Okay. Okay. Today we will learn about the fan principle. Like fan is a prime mover and air system or ventilation system, and a fan is a essential component of all heating and air conditioning system. Thus, it is necessary to distribute air through the ductwork to space that is to be air conditioned. Yeah. So actually, this part is very important to distribute air distribution to the zone or area. So without a fan, so we cannot deliver the uh, weather in the heating condition or a cooling condition. Yeah. So an understanding of fan type and its performance is necessary to design a satisfactory duct system. So we will touch about this also. And then fan may be classified into three main types, such as a centrifugal, axial flow fan, and special designs. So actually, based on the implement of the fan, so maybe we will be varied condition. So we will select based on the application. Yeah. So because sometimes we need an implement in the inside of the duct system. Sometimes nearest to the zone. Sometimes only close to the uh, from the hatchback system. Yeah. So mean from the source of the hatchback, and then we will deliver to the into the duct system. So which type will be efficient or good in the hatchback application. Okay, this one is look like the uh, uh, what type is meant like the centrifugal because we try to the using the centrifugation force to the distribute the uh, uh, air. So look like snail, snail a pattern, because the centrifugal force will be work on the side, in the uh, uh, radial side of the radial of the distribution flow. Okay, centrifugal. Fan type. Centrifugal is a pulled along fan shaft and blown radially away from the shaft. Okay, we should be understand first which one the part of the axial. So axial will be uh, uh, similar direction in shaft. Yeah. So we can see is the motor is have rotor and stator. Yeah. So the stator will be put under similar to the shaft. So shaft itself, a middle in the motor. So you can see this one is a shaft direction. So in the shaft direction will be uh, we can say this one is in the uh, axial direction, while when the radial is mean uh, perpendicular from the axial, mean that there will be force will be around the 90 degree from the axial, so will be here, yeah, around the tip of the blade, yeah. So this one will be forced to the centrifugal, so that direction we call radially, yeah. Air is usually collected by scroll, casing, and concentrate into the one direction. So we should be understanding also the blade will be around the casing, yeah, here inside, yeah, in the radial direction, mean will be rotate, yeah, similar into the shaft direction, and then the blade will be 90 degree, yeah, from the uh, maybe around none, and maybe will be performed like the certain angle from the 90 degree, maybe certain angle, based on the design from the axial direction. So the casing will be function as the stator, and then the blade uh, will be uh, move lah, as motion in the casing. And then the direction you can see here is uh, perpendicular from the axial. So axial will be here, and then this one is from there. Yeah. Commonly used in the ducted aircon system, so will be construct in the duct. And six type in under the centrifugal type. The first one is forward curve, backward curve, radial tip, radial blade, foil, and backward incline type. Yeah, so we have six there in the under centrifugal. Yeah, this one will be uh, easy to recognize. Yeah, in the centrifugal because we have direction is perpendicular, yeah, perpendicular from the axial. Now we go to axial, yeah, flow, yeah, this one. So you can see blade, yeah, blade here. So the airflow will be go, yeah, through similar direction uh, to the shaft direction, yeah. Mean that, yeah, will be zero of degree, yeah, from the shaft. So air pull along the shaft and blown along in the same direction. So we will attach, easy in the duct system. Yeah, maybe just install into the duct. Maybe we can install in the this one is round type of duct, and then the flow will go through directly to the blade, yeah, in the similar direction. Okay, in this type is will be have three types, yeah, of fan, yeah, propeller, tube axial, and vane axial type. Okay, now we can see why is the different. The centrifugal fan and with the uh, axial flow type of the fan. So we have six type here in the centrifugal. You can see the first radial blade, and yeah, the radial blade. Yeah, this one is blade. Yeah, so similar to the uh, 90 degree, from the uh, axial, from the axial direction, and then maybe some design with the several direction. I mean the angle will be create in the certain angle from the axial. We can see. So this one we call the incline, The other we can airfoil, so the blade will be designed like the airfoil pattern. The blade type will be designed like the airfoil. So airfoil type is look like the cross sectional of the wing, mean the no not wing, mean the uh, wing of the airplane. Yeah, so the cross sectional is look like the airfoil. Yeah, same like the wing of the airplane. Yeah. And the airfoil type we can recognize also like the blade of the helicopter also, and then they will be create like uh, pattern of the airfoil. And then radial tip is you can see only certain tip perform like the radial, and then will be maybe not so wide, yeah, like the radial blade, uh, but only certain on the tip, yeah, certain part on the blade, and then that one we call under radial tip, yeah, type. And then backward, this is only direction, yeah. Actually, the direction is opposite way from the radial tip, and then we call this one is backward. And then forward, yeah, it's depend on the direction, yeah, we call backward or forward. And then in the axial, yeah, we have three types, yeah. The propeller, tube axial, and then vane axial. So you can see what the difference is within the stationary vane and then the tube axial. So we have some part here. We call the stationary vane, and then this one will be uh, different to the tube axial. So this one is in a tube. This one is open. All right. Okay, now we touch about the differentiate within the forward and then backward in the under centrifugal fan. So we can see in the forward curve, lower initial cost than backward. In the backward curve is higher initial cost. Okay, so why we invest? So we should be recalculate in our design of hatchback what we need to uh, uh, implement in some components. So in some component we also consider the investment cost, not only for performance but also in the uh, investment cost. So maybe we need a high performance. Maybe we can select uh, the good design with the high cost. But maybe we can reduce the cost maybe by maintenance, low maintenance. So we can pay back the high cost, high investment cost by low of maintenance. So high operating system, so lower operating cost, so we can pay back by lower operating cost. So by maintenance also, higher operating system, higher efficiency, lower efficiency, limiting horsepower. So will be balanced based on the uh, investment cost. So what we get uh, by what you pay. Okay, that's how we get. So same like the when you buy the car, so you get what you pay. So same like this hatchback design. So you can pay with the low cost, but maybe we will pay in the operating and high maintenance. So uh, depend on the client. So what they need. yeah, uh, to uh, running the hatchback system. The rising BSBB characteristic curve result in overloading the motor when operating beyond selected CFM. So this one is a differentiate within the forward and backward of curve under the centrifugal fan. So in the radial, within to the airfoil blade, the blade are radial. A name is derived from the airfoil shape of blade. In the performance, generally less efficiency of the centrifugal fan developed to provide high efficiency in the under the low under radial blade is low volume at high pressure. Under the airfoil blade, use a large hatchback and clean air industrial system. So same thing like the backward and forward blade. So you can choose based on the client requirement. Okay, radial tip. The blade are radial to the fan shaft at the outer extremity of the impeller, but gradually slope towards the direction of wheel rotation. More efficient than the radial blade, but less than a backward incline. So, yeah, same thing, yeah, like previous one. So, uh, but the point is how to you select based on the application. Okay, now we touch about the other type of the fan. We go to axial flow fan, yeah. In the tube axial, so we can differentiate with the vane axial. So the distribution is uneven, the suitable for ducted aircon system. So air distribution is the same like the normal or normal fan, yeah. Uh, but this one is vane axial is more than the like for the duct system, yeah. Undesirable for aircon system, yeah. And this one is vane axial is for the uh, aircon system, yeah. Okay, that's how we can differentiate within the tube axial and vane axial. Okay, just a normal fan is just use axial flow fan, yeah. Uh, Maybe that one is for the uh, residents only, yeah. It's not for hatchback application. Okay, special design fans. Special design fans of the required quality, demand, design, innovation, exotic material, and precision manufacturing technique. Okay, when we try to select the fan, proper fan in our designing, yeah. So what we need is based on this parameter. Sometimes we can choose because of innovation. Sometimes we can choose as a material and then precision. Yeah. So, but the best thing is when we choose is for all parameter that improve the performance. Yeah, will be considered. Yeah, this one should be. Uh, satisfied for all criteria. Okay, you can see this one is a type of the fan. Okay, now we go to the uh, design, yeah, in the blade, or we call impeller design. So you can see inside of the casing, yeah, maybe difficult to see the blade, yeah, type. Maybe we can see by sometime through inside, yeah. to uh, check what type the fan or blade into the uh, close or casing system of fan. So now we can see this impeller design for mixed flow, cross flow, and other design. You can see this one. So uh, you can understand the characteristic. Each fan will be perform the characteristic. So which one will be selected, based on this characteristic. So the first one we can see when the mixed flow. So you can see you can choose this one, and cross flow you can see you can choose this one, and then turbulence this one. So depend the application the condition part when you implement the HVAC the system. Okay, this one, the mixed flow, combination of axial and centrifugal characteristic ideally suited in the application in which the air has no flow in or out axial. Higher pressure characteristic than axial fan. So if you want to implement, yeah, within the written air and then within the uh, fresh air, you try to mix within them, within the written air and then so we have the one part in the HVAC before uh, we utilize this air to the AHU just before AHU. So we have a mixing part within the written and then with the fresh air. So better we can select this type of the fan. Okay, this one is good, So then we go to cross flow centrifugal. Impeller with forward curve blade during rotation and flow air of passes through a part of the rotor blade into the rotor. Discrete on the area of the turbulence, which working with the guide system, deflect the airflow through another section of the rotor into the discharge duct of the fan casing. Lowest efficiency of any type of fan. So this one maybe already mentioned about the lowest efficiency, yeah, compared to other fan, because you can see, the tip, of the blade, only work to collect or to deliver the air, into the duct system. So mean that the efficiency will be low. So just only for maybe this one is high, maybe not for high speed of flow needed, and maybe we can use this type. Yeah, this one. And then when we go to the other design, tubular centrifugal that have maybe blade is inclination, and also maybe uh, more wide, or more biggest, compared the tip blade, So maybe this one will be delivery a much of air distribution compared to previous one. Okay, performance similar to backward curve. Fan except capacity and pressure are lower efficiency than a backward curve fan. Performance curve may have a dip to the left of the peak pressure. So you can see, already mentioned, this one is good in the performance, by the high pressure. So this one is a good for consider in the hatchback design. Other than that, we can also have the centrifugal and the axial. So low pressure exhaust systems such as general factory, kitchen, warehouse, and some commercial installation. So we can use this type. Provide positive exhaust ventilation, which is an advantage of a gravity type exhaust unit. Yeah. Centrifugal units are slightly quieter than the axial unit. So that one is we can implement. Yeah. Only is yes. Any question? No. Okay. I just you don't have any question, so I can continue my presentation. So now we go to the axial. Axial, as we known in the previous slide already learned, the direction is similar to the shaft direction, mean that the flow will be go yeah, from the axial direction. So low pressure exhaust systems such as general factory, kitchen, warehouse, and some commercial installation provide positive exhaust ventilation, which is an advantage over gravity type exhaust unit. Uh, could protect fan from the weather and act as a safety guard. Yeah. So sometimes we can use in the exhaust system. Yeah. For uh, living to the maybe to the collector or to the outside. Yeah. Okay, fan performance and characteristic. It's well known that they are that the air flow in the duct encounter resistance due to the friction. To overcome this resistance, energy into the form pressure must be supplied to the air. Rotating fan impeller exert a force on the air, resulting in a bulk flow on the air and increasing the pressure. The volume, flow rate, and the pressure created by the fan is called a performance characteristic. Performance characteristic consider CFM, pressure, efficiency, and BHP. Useful for correct fan selection and proper operating and troubleshooting procedures, best understood when presented in form of curve. Actually, when we talking about the performance and characteristic, it should be we can measure anything we can measure. In engineering, it should be measure in the value characteristic. So, let's say we can say uh, this car is for a high speed. Yeah. So how much? How we can consider this car is high speed? So you can say if the speed is more than 120 kilometer per hour, we can consider as a high speed. Then when opposite meter reading mean that the lower to the 120 kilometer per hour considered is medium speed until to 80, and then below the 80 we can call is low speed of the car. So this number will be guide us uh, uh, to decide whether this one is considered low, medium, middle, or the high speed. Same thing like when we call this one is good, efficiency, performance, we should be give by the number. So in this case, the fan performance is measured by The performance is by pressure, efficiency, and BHP. Yeah? Uh, then we can call this one is uh, satisfies in the uh, performance. And then also characteristic. Yeah, as mentioned before, we have several type of the fan, and then the characteristic is different. So we can say the pressure is low, pressure is high, yeah? And then what else? The CFM is low, and then turbulence is high. Yeah? So we can say that high. We can measure something to describe uh, something. Yeah, if we measure the weight, then we should be mention the mass in the gram kilogram, whether in the SI or the British unit. So that same thing to measure fan performance and characteristic. So under the fan performance, yeah, based on this slide, describe is anything about the characteristic, yeah, and then the performance. Okay, let's say uh, the characteristic, yeah, we category criteria like the maybe uh, your rotating fan impeller exert force on the air. So how the characteristic is impeller type, yeah, can come with the air distribution output, yeah. So maybe turbulent, maybe low of the amount, low in the maybe the speed, yeah. So we can say like that, that from the characteristic of the blade or impeller. Yeah. Okay. When we go to performance, how do we measure the performance? Yeah, from the CFM, pressure, efficiency, and BHP. So these all criteria will be discussed uh, uh, in this topic, yeah, in under the fan characteristic, yeah, performance, sorry. Useful for correct fan selection and proper operating and troubleshooting procedure, so we can know once we select that fan model type, and then we know to handle the this fan. Maybe from the installment, starting from the installment, and then what we can receive, yeah, in the CFM, yeah, and then what the energy uh, consumption, and also the speed, yeah, velocity uh, of the flow, and then also the maintenance we know to uh, understand to maintain the uh, through the scheduling of maintenance. Okay, actually, uh, in the performance, this one is a parameter or properties we need to satisfied, yeah, before we consider this performance is low or is good, yeah, in the uh, fan performance. Okay, the first is CFM, yeah, volume flow rate, and then static pressure and total pressure in sorry double typo on the PT. PT only the total pressure. The total pressure is a sum within the static pressure and dynamic pressure. BHP, brake horsepower, energy consumption, and HP horsepower. So we have differentiate, yeah, within the BHP and the HP actually. If you realize, yeah, the BHP mean that when you try to uh, running, yeah, the fan, so different speed, yeah, will be consume different energy. So this one we call the BHP, but the horsepower mentioned, this maxima or the power can implement in the fan itself. Yeah. So actually the power is the fan. Yeah. Will be varied based on the size, yeah, of the fan. And then speed. Speed. This one is common. Yeah, common terminology when we talking about the something related to the rotating. And then mechanical efficiency, ME. We can determine by formula HP divided by BHP. Yeah. Okay. When we plot, yeah, within the pressure, efficiency, horsepower to the flow rate, and then inside there we have the mechanical efficiency, static pressure, brake horsepower. This one is characteristic, yeah, of uh, the fan based on the performance. So you can see actually when we operate, yeah, fan in the efficiency, we cannot get in the high efficiency on the high flow rate. Yeah, because when we try to run fan, yeah, by high mechanical work, yeah, that means it's close to the maximum of the power of fan, and then we cannot get the good in the uh, mechanical performance. So the efficiency also, yeah. So maybe around the maximum we can use is around 85% of the power. We cannot use the more than that, so the efficiency will be dropped. So the maxima will be when we touch about the mechanical efficiency is almost is around 50%. Yeah, and then when we talking about the brake horsepower, the maximum is when the maximum of flow rate, and then when we talking about the static pressure is maybe same like the mechanical efficiency is around 50%, yeah, of the power. So from these three of the performance, we need to have the cross section, yeah, to meet a good for all performance. So we need to create or not create mean the uh, reach, yeah, reach a good performance by three of this performance. So we need to meet, yeah, from this characteristic, yeah, from this characteristic. So we cannot use the maxima for the mechanical work, and then we cannot use the static pressure, yeah, because the static pressure which will be uh, avoid, yeah, the condition in the uh, low of pressure. So what we need is to be maintain the static pressure in the high, and then we can deliver the air distribution. So we have the maybe uh, around here, and then we can meet, yeah, the good performance. The same thing when we're talking about the uh, other characteristic, yeah, of the fan, yeah. when we talking about the backward curve blade centrifugal fan. So we need to something, yeah, uh, to meet all a good performance. Yeah. Let's say this one, yeah, is for static pressure, and then the brake power is supposed to be here, and then mechanical work is here. So maybe we can meet here. The the all performance will be good, yeah, in the 50%, yeah, condition, around 50%, not more than the 70. So around 50, within 50% until to 70 percent, yeah, of mechanical work. Yeah. So then we can meet all good performance. And then for previous one in the blade, type, yeah, forward curve blade centrifugal fan, maybe around, maybe good condition in the also 50, yeah, maybe 50, yeah, 50%. That's how the characteristic of fan will be run based on the characteristic, yeah. For both forward and backward curve blade centrifugal fan, the P developed as a slight peak in the middle range flow, then the P drop of the as flow increase. Yeah. So I said just as same like I mentioned before. So the BHP required for the forward curve blade fan increases sharply with flow, but with backward curve blade fan, the BHP increase only gradually, peak at a maximum and then fall off. So careful. Uh, so every type of the fan will be come out with this plotting characteristic. Yeah. So should be careful when we use the or we run the hatchback system. So will be maintained. So the engineers will be now. Let's say this hatchback system will be implemented in the uh, a shopping complex. So the engineers will be now. We cannot go uh, until to 70% of the mechanical work, or we cannot go until to the 80% of mechanical work to avoid the uh, uh, inefficiency. A higher maximum efficiency can be achieved with the backward curve blade fan. Okay, yes, of course. If you compare both type, so the characteristic is better. We use the this one, this type, yeah. Okay, example, what static pressure PS will the fan whose performance curve are shown in figure below, developed at the delivery of 20,000 CFM. What will be the BHP and mechanical work at this condition? So solution at the intersection of 20,000 CFM and then static pressure is 5.8 inch water gauge, and then this CFM BHP is 42 horsepower, and mechanical work is 85%. So based on the CFM given is 20,000 CFM. So this one is based on the characteristic of the fan, yeah. This one. So we can relate into the fan characteristic. Okay, this one is mechanical work, and then this one is the uh, static pressure, static pressure. Then this one is BHP, and then we can measure to relate. the maximum mechanical work here, 20, and then this one is around BHP around 22, 42, sorry, 42. All right, that's how we determine the good performance, in the uh, fan utilization, Okay, now we go fan rating. Performance curve, in the fan rating enable engineer to visualize change in BHP, static P, and efficiency available from a manufacturer or can be predicted from the fan. Okay, before we decide to select the fan, so better we ask from the supplier or manufacturer to come up with the characteristic fan with all parameter like BHP, pressure, and what else just now, and CFM, condition. So with that characteristic, we can decide which uh, condition will be shown in the good or maximum performance. So we can operate this fan only that range. Yeah, we can maintain on that range. Yeah. Table replace large number of curve, use more often, operating condition at the maximum efficiency is not clearly understood. Some manufacturer resolve by nothing the point of the maximum efficiency interval. Okay, actually we can table it. The number, what number. Sometimes difficult to rate the curve. So we can only certain people maybe can read very sharply or very accurately. But if we table it, this number, so we can run or operate the fan based on this number, this numeric number, yeah, through the table. That's how to maintain the performance. Okay, before we go to how to select a fan, so I need to take a 5 minute, to break. But during 5 minutes, so you can disturb me uh, if you have any question. Yeah.
Okay, sir.
Okay. Okay, let's continue uh, to next slide. Now we talking about how to select a fan. So the slide already given the criteria how we can select the fan. The first one is by static pressure resistance or PS is calculated. So we need to calculate it first to define the pressure resistance. Yeah? And then from manufacturer data, the required CFN, again, the system static pressure resistance for the right fan is selected. Yeah, so we need there. And then we can make the curve. Yeah, and then we can plot which the best solution. Yeah, for good performance based on the plotting graph that given. And then the last is selection criteria, energy consumption. So how we can BHP selection, yeah, and then we can decide, yeah, which one the fan will be used in our design. So this comment, yeah, above was conventional way to select a suitable fan for hatchback system. Nowadays, the ensure the best chance to minimize energy consumption. Total pressure must be used. Okay. Nowadays, they try to select that fan given by uh, low energy consumption, yeah, and so maybe, yeah, we can select the type based on the energy consumption. Some maybe will be the type, yeah, based on the type maybe will be consume the higher energy. So maybe we can select based on the low energy consumption, but already satisfied the CFM, yeah, and also the all delivery requirement in the uh, hatchback area. Okay, let's say we have already plot the condition of graph within the BHP, and then with the static pressure, and then also with the uh, uh, horsepower. So we can decide that, yeah, the best uh, uh, consumption, in the volume flow rate is around here, and then we can select what type of the fan. Okay, this one is the best thing to satisfy all criteria. Okay, uh, okay, that's how we select the fan. Okay, now they have a tablet, yeah. After they make the curve, yeah, and then uh, they try to tablet, yeah, of this numeric number, to make us easy to select of the fan, yeah, for our designs. Yeah, for example, this we divide by model, and then we divide by column of the horsepower, rotating number, rotation per minute, and then the static pressure inches of water gauge. So based on this, we can select, yeah, easy by given numeric number. All right. Okay. After we plot, yeah, here plot by graph, and then easy to select which one based on the type. which one will be satisfied, yeah, our design. Okay, let's say this one is satisfied for our design, and then we choose this one. All right. Okay, for fan laws, yeah, uh, we have here a relationship among uh, fan performance for a given fan operating at change condition or for different size fan or similar construction. Yeah. Okay, this relationship, yeah, fan performance operating at change condition or for different size fan. Yeah, useful to predict performance when conditions are changed. It's not practical to test every fan at every variable which may be encountered. Yeah. Fortunately, by use of the series of equation, commonly referred to as the fan laws, it's possible to predict with good accuracy the performance of the fan at other variables. Yeah. So that all is for fan laws. So it should be in this range area criteria, yeah, when we select of the fan. So we should try to uh, still on the track, yeah, to select the fan. And then, yeah, such based on the speed, yeah. So actually they have a connection or relation, yeah, within the size, yeah, within the speed, speed to size, and so on. We have also relation within the CFM, to the speed, and also the pressure, static pressure to the rotation, yeah, and also horsepower to the rotation, and then CFM to the size. So actually they have a relationship. Then actually they should be now, yeah, when we to determine unknown properties, yeah. So let's say we don't know P2 when we know the D diameter. So we can determine the P2 by this fan laws equation. Okay, we have the example here. Okay, given a fan delivery is one a 10,000 CFM at 1.85 inch water gauge, and the CFM. Oh, sorry, this one is this property is a density, mass over to the volume is density, and then the RPM is 600, and then horsepower is 3.4. Find the corresponding performance of the same fan at the 12,000 CFM, and then this property, of the properties. Okay, we can relate this one is by the formula Q1. Oh, this one is sorry, this one is density, density. So we can use this formula. Uh, so then we can determine, yeah. Maybe this one is CFM and horsepower. Maybe we need to determine the horsepower. So what horsepower we need, yeah. So let's say the Q1 is 1,000, and Q2 is 12,000, and then horsepower first is 3.4, and then horsepower 2 is unknown, so we can determine. So anything we can determine this from this relation. Yeah, like the other, maybe we can refer to this table what we need to uh, determine. Yeah. Uh, so like see pressure, so you can see the pressure also, RPM, yeah. So you can determine from this formula uh, RPM, and then with the rotation. So then we can determine and tabulate answer. Also same like the second example, same thing. We can repeat it the method, same how to determine anything. So still unknown, just determine, yeah, the and satisfy the question. So I think that's all for today. If you have any question, we can discuss here.
So far, okay, sir.
So far, okay. Okay. Uh, what the Miss Ain mentioned and previous in your class, yeah. So we will conduct the midterm test next 19 May, 19 May after semester break, yeah, season. So and then we can conduct the midterm test, yeah. Okay, if you don't have any question, I will go to the attendance, yeah. Chu, ada Chu.
Yes, sir. The
And then Kartik ada.
Yes, sir.
And then Muhammad Irfan Indrawati. Irfan. Muhammad Izmul Faris bin Azman.
Yes, sir.
Muhammad Izzad bin Saleh. Muhammad Izzad. Muhammad Umarul Adin.
Yes, I do.
Muhammad Sazwan Zulhilmi. Muhammad Sazwan Zulhilmi. Muhammad Adib bin Muhammad Nur Adnan.
Yes, sir.
Muhammad Adib Hakimi bin Zamari. Muhammad Adib Hakimi. Muhammad Aiman Haikal. Muhammad Aiman Haikal. Muhammad Akmal bin Muhammad Nur.
Yes, sir.
Muhammad Amir Syafiq bin Muhammad Ramli. Muhammad Haris bin Johari. Muhammad Haris bin Johari. Muhammad Hazim bin Ahmad Zulkifli.
Yes, sir.
Muhammad Hazim bin Mansur. Muhammad Hazim bin Mansur. Muhammad Izzuddin bin Mukhtar. Muhammad Izzuddin bin Mukhtar. Muhammad Mustaqim bin Rosman.
Ada, sir.
Muhammad Sufyan bin Mazlan.
Ada, sir.
Muhammad Syahir. Muhammad Syahir. Muhammad Syahir bin Ma'ruf. Muhammad Syahmi Mualib. Muhammad Syahmi bin Mualib. Nabil Aiman bin Alias.
Yes, sir.
Nur Aiman bin Nur Aiman Naim bin Cik Ibrahim. Nur Aiman Naim. Parani. Parani. Umarul Hakimi. Umarul Hakimi. Wan Ahmad Syakir. Wan Ahmad Syakir. Tak ada. Ramai yang tak ada hari ni.
Sir, Muhammad Irfan ada sir. Saya pergi tandas.
Okey, okey. Muhammad Irfan nombor 4. Okey, siapa lagi? Okey, kalau tak ada, kita tutup kelas ni ya. Okay, we close and see you next 2 weeks. Next 2 weeks. Alright, Assalamualaikum and good afternoon.